Good afternoon and welcome to this recording where I'm working out 3 problems specifically for my college physics summer 2016 batch. In the first question, in a relay race, runner A is carrying the baton and has a speed of 3.4 meters per second. When he is 25 meters behind the starting line, runner B starts from rest and accelerates at 0.140 meters per second squared. How fast is B traveling when A overtakes her? So A is 25 meters behind B and is moving at a constant speed of 3.4 meters per second. Now, B starts from rest, 25 meters ahead of A, and is accelerating. So, to pass the baton, A and B will catch up. So, at that instant, you have to find the speed at which B is traveling. So, that's the question. When you draw the diagram, so if that's the position of A and that's the position of B, so you have A is 25 meters behind B when B starts off, and we'll call this distance BC as X, which means that they're assumed to catch up at C. Therefore, during the time that A takes to reach C, during that same time, B goes to C. So the time that A takes to reach C and the time that B takes to reach C are equal. Therefore, for A, because the velocity is constant, there's only one equation you can use, which is velocity is displacement divided by time. So velocity is 3.4, the displacement is 25 plus x, that's for A, divided by the time, which we do not know. So there are 2 unknown quantities there, both x and t. Now in the case of B, this is a case where there is a constant acceleration. So we will use the king, I call it the king, which is x is equal to v naught t plus 1/2 at squared. And when you plug it into that, because the initial velocity is 0, this whole term becomes 0. So you have 1/2 times the acceleration times the square of the time. Once again, there are 2 unknowns, x and t. So that simplifies to 0.07, which is what you get when you divide 0.140 by 2. So now you have 2 equations, and now comes the math part where you have to solve the 2 equations. Now you can substitute the value of x here into this equation. So it becomes 3.4 is 25 plus, in place of x, you put the whole value of this, and then you get divided by t. You rearrange the time, you get that, and that builds up to be a quadratic equation. When you take them over to the other side, this is what you get, 0.07 t squared minus 3.4 t plus 25 is equal to 0. Now that's the A, B, C. Remember that quadratic equation is of the form ax squared plus bx plus c is equal to 0. And although I've not written it right now, this is the formula for solving a quadratic equation. let me write that. So you know how I get those numbers. It's minus b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So now you understand that since b is negative 3.4, that's why you got 3.4, because two negatives make a positive. Plus or minus, that's the square of 3.4, b squared minus 7 is actually what you get when you multiply 4 with 0.07 times 25. So that gives you 7. Okay, so and then divided by 2 times a, 0.07. When you plug in all that and solve, you get 9 seconds. Now, in order to find the final velocity, you can use the equation Vf as V naught plus At. You're looking for the final velocity. The initial velocity of runner B is 0. The acceleration is given, 0.14. Multiplied with the time that you got, 9 seconds, and you have the speed, or I mean the final velocity, which is 1.265 meter per second. When you round it off, you get 1.3 meter per second. So that's how you do that problem. In this second question, you have an object that is thrown upwards with a speed of 14 meter per second. How long does it take to reach a height of 5 meter above the projection point while descending? So you have the initial speed or initial velocity, and you have to find the time that it takes to reach a height of 5 meter above the point of projection, but while descending. So that means this object goes way above that point and comes back down. So the initial velocity is 14 meter per second. It's thrown straight up, so it's going up, and it goes, that's 5 meter, that's where you have to find the time, but you know, it goes straight up and comes back down. So that's what you have to understand. So you got to find the time to pass this point, but not on the way up, but on the way down, because there will be 2 times when it crosses that point. One's on the way up and the other on the way down. Okay. So what are the quantities? V naught is 14 again. 14 meter per second. Acceleration is negative 9.8 meter per second squared because it's going up. We know that. The displacement is 5 meters. And you're asked to find the time. So when you plug it into this equation, delta x is v naught t plus 1/2 at squared. Delta x is 5, and you have 14t, and 1/2 times negative 9.8 is going to be 4.9, negative 4.9. So that's how you have that. Once again, you end up with a quadratic equation when you rearrange. And as explained in the last question, if you use the quadratic formula, this is what you get. Remember, A is 4.9, B is negative 14, and C is 5. So when you plug it into that formula, and solve, obviously you're going to get 2 answers. One will be the time to reach that point when it's ascending, and the other will be the time when it is descending. So you got to go for the longer time because that'll be the time when it's descending. So what I've taken is just 14 plus 9.9 by 9.8. I have not even written down the smaller answer. So once you have that time, you're good to go. You got the answer to that. And here is the next question. To find the height of a flagpole, a ball is thrown straight up, and just like in the other question, it takes 0.5 seconds on the way up to reach the top of the pole, and again goes way above that and comes back to the top of the pole at 4.1 seconds. And you got to find the height of the pole above the point where the ball was launched. Now, because we did the previous problem, this must be easier to understand. Here is the diagram, well explained. I'm labeling those points A, B, and C. And we will start with A, B. That's what you have to find out, which is our displacement. You have to find the height of the pole. Now, acceleration is negative 9.8 meter per second squared. We do not know the initial velocity with which it was thrown from A, but we know that the time it takes to reach the top of the pole is 0.5 seconds. So this is V naught. So you now have two unknown quantities. If you have to find the height of the pole here, you have to have the velocity with which it was thrown, because every single equation that we use has the initial velocity. So first we have to find that. Now, in order to find that, what we're going to do is we will consider the motion BC. What we'll do is we'll find the initial velocity at B. You know why I do that? Because from B to C, the total displacement is 0. And we do know the time that it takes to go from B to C. That would simply be the difference of 4.1 and 0.5, because at 0.5 it reaches there, and at 4.1 it reaches there. So the time that it takes to go from here to here is 3.6 seconds. So the displacement is 0 from B to C. We are looking for the initial velocity at B now. Don't be confused. We're looking for the initial velocity at B. A is still negative 9.8 meter per second squared. Time is 3.6 seconds. Use the equation. V naught t plus 1/2 at squared. Substitute the values that you know. Again, 1/2 times negative 9.8 is negative 4.9, so that's why you have that. You get 63.5 when you do all this part. Rearrange and calculate. Actually, it's going to be 63.5 divided by 3.6. That's how you get 17.64 meter per second. Now, that means that's the velocity of the ball when it reaches B. So that initial velocity at B is actually the final velocity of the path AB. The velocity at B is the final velocity of this path. Now we can use the equation. Vf is V naught plus AT. Remember, the final velocity of the path AB is 17.64. So V naught minus 9.8 times 0.5. From that you can find out the initial velocity at A, which you get as 22.54 meter per second. Technically it's 22.5. Okay, so now that you know the initial velocity here, you know that the time it takes to go there to B is 0.5 seconds. You know the acceleration is negative 9.8 meter per second squared. You can now find the height of the flagpole. So back again to AB, we're trying to find the height of the flagpole. Let me speed this up a little bit. Now we got V naught, so I'm going to change it to 22.54 meter per second, and again use the same equation and calculate the height of the flagpole. Well, that's a mistake. I got to have a negative there, okay, because it's going up. And when you do that, you get 10 meters, and those are the three questions that are really important. What you need to do is to understand how these questions are done, because they have multiple steps in the process, and really, if you can do these problems, you are good to go. Thank you. Hope you enjoy studying physics.